welcome back. I just realized that I was counting down the, starting the recording. I went in 3, 2, 1, and then I confused myself. So if you saw me making a confusion face, that's what it was about.
Oh.
Welcome back. We're continuing our studies with quadrilaterals. We're going to be looking at the trapezoid and the kite. Quick review of what we've already done. We've already found a way to calculate the total sum of all the angles inside a polygon of any number of sides. That is going to get used today. We've also talked about parallelograms, the fact that you need two opposite sides parallel to each other in order to have a parallelogram. You need two pairs of those, so it feels like I'm voguing when I do the hand motion. Sad that there's no face cam to show you, right? We talked about rectangles, where you took a parallelogram and then you made a corner a right angle. Then, last time that we met, I think yesterday, we did rhombus and square. Rhombus was all four sides equal to each other, also a parallelogram. And the square had to also be a rectangle in order to be a square. So rhombus and rectangle together made a square. Today, all about the trapezoid. Here we go. A trapezoid. We're playing Geometry Mad Libs today. A trapezoid is a quadrilateral, that is a four-sided figure, with exactly one pair of parallel sides. Remember that a pair is two things, so you're going to have two sides parallel to each other for one pair of parallel sides. The parallel sides are called bases. It's all about the base. These are bases. They're parallel. I've been trying that song all day and it hasn't worked. One of these days. All right, there's your bases. Note the symbol for parallel drawn in them. There it is, the little extra arrowhead somewhere in the middle. The non-parallel sides are called legs. And here are your legs. The angles that are formed by the base and the legs have a special name. They are called the base angles. And so the base angles are the ones that are formed by a base and one of the legs. So this would be base angles right there, those two. Flipped on the other side, those are also base angles. We have a special segment called the mid segment, also known as the median. That word hopefully seems a little familiar from our triangle days. The median in a triangle, please recall, went from vertex to midpoint. And so mid-segment or median in trapezoid is going to go from midpoint to midpoint.
It creates two congruent segments as well.
Yep, and we're going to have congruent sides on each leg on opposite sides of that midpoint. This line then is our median or our mid-segment. You'll hear me jump back and forth between both of those names for you as we move through today's lecture. Its measure, that is the measure of the median, is going to be equal to 1/2 the sum of the bases. We'll write that sentence as a formula a little later on down at the bottom of the page. Next item. If the legs are congruent, then the trapezoid is isosceles. And so we will call it an isosceles trapezoid. In an isosceles trapezoid, both pairs of base angles, yes, sir, they're going to be congruent to each other. In addition, we get as an added bonus the diagonals are going to be congruent. A lot like what you saw in the rectangle, which is going to make trapezoids feel like this weird rectangle-y, not rectangle.
So it's like a isosceles triangle, but with as a parallelogram.
Right. Well, not a parallelogram, as a four-sided figure, as a quadrilateral. Because parallelogram is a specific where you have two sets of parallel sides, and this thing only has one set.
Just a four-sided.
Yeah, it's just a four-sided figure. All right, let's write down our Isosceles Trapezoid theorems. You can find these also in your textbook if you're having a little trouble seeing. I know that the type is small and I'm zoomed out really big, but I want to be able to see all the picture on it. So I'm sorry if it's a little too small. Again, in your textbook, 439 is where I have these listed. Okay, if a trapezoid is isosceles, then each pair of base angles are congruent. And I'm totally abbreviating because I don't have enough space.
And we can't do?
Huh?
Can we?
We're going to write the answer to this example. Yeah.
Is it better?
All right, so in this trapezoid FGHJ, these angles are going to be congruent. Note that they are, whoops, they're congruent. Note that they're along one base. And then these angles right here are also congruent. Okay. If you're told, hey, this is a trapezoid, and you get told that you have one pair of congruent base angles, then you can say, hey, boss, the trapezoid is isosceles.
Oh, so this is just the converse to that.
Exactly. So if angles L and M are congruent to each other, then trapezoid does not have a cool little symbol, so you're going to have to write out the word trapezoid. Sorry, bruh.
Can we create?
We cannot create one unless you get really high end in the annals of math, in which case I guess go ahead and fix all of our symbols because the math symbols are really weird and I don't like some of them. Okay, okay, let me start again. Next one. A trapezoid is isosceles if and only if, this is what's called our biconditional. This allows us to go both forward and backwards within this statement without any concern. A trapezoid is isosceles if and only if the diagonals are congruent. Once again, my timing is awesome.
Amazing.
I know, right? This says that if we have a trapezoid, QRST, and it's isosceles, then the diagonals are congruent. QS is congruent to RT. But likewise, if we were told we had this trapezoid and we knew that the diagonals were congruent, then we could say the trapezoid is isosceles. Earlier I promised you that we would write the mid-segment median relationship of measurement as a formula. Here it is. The mid-segment of a trapezoid is parallel to each base, 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 mid-segment median. And its measure is equal to 1/2 the sum of the two bases.
It's 4 and base 2.
Let's fill out the example just so that you get that practice of we're filling in the formula, and then we're going to use a lot of this stuff coming up in just a bit. If BE is the mid-segment of trapezoid ACDF, like in this picture here on the right, then line segment AF is parallel to line segment BE. Line segment CD is also parallel to line segment BE. And the measure of BE, notice the difference in the symbols. all here I was reading line segment BE, line segment B here, and here I said the measure of BE. Okay? All right. The measure of BE equals, I'm going to use this formula. It equals 1/2 whatever I get when I add the bases together. Give me the name of one of the bases. AF. And the name of the other base?
CD.
And if you got told any two of those three bits of information, you could find the third. Let's practice this. Turn the page. We're going to look at numbers 3 and 4 first. I have this down today. All right, 3 and 4 first toward the middle of the page. We are told that we have a trapezoid. We're also given its name, HJKL, and we're told that M and N are midpoints. So here and here are midpoints. That means that these two pieces are congruent and these two pieces are congruent, and those two lines are, well, I suppose 3 lines, are parallel to each other. There's our trapezoid, and we know which one's our mid-segment, yes? Which one is our mid-segment? Right here, MN. Here's our mid-segment. I wrote median because it's the same thing. And then here are our bases. Notice that I'm reusing the colors from before. All right, now I'm going to do both of these examples for you, which is going to be interesting because I only have one figure. And in this one figure, the segments are getting reused over and over again. And so it's hard really sometimes to tell which segment we're working with, okay? So I'm going to use colors to help us tell the difference between which segment in which problem I'm dealing with, okay? All right, HJ. I was told HJ is 32. So HJ, this one right here, is going to be 32. And then LK, right here, this one, is 60. And then it wants me to find MN, which is this one right here. So I'm going to put an X for a variable. All right, I have relationship between the measures of bases and medians, and that is my formula that the median equals 1/2 times times whatever we get when I multiply, or excuse me, when I add the bases. God, I cannot talk today. All right, which value is my median? MN, which has a value of X. Which value represents one of my bases? HJ 32. And then the other base, which is LK 60, goes in the other place. And now I can start to reduce this down. So X equals 1/2 times
92.
Thank you. That means that X has a value of 46. Thank you. I was about to get there. I was like 40 and then carry the, which means this is MN, which is what I was trying to find. Okay. We're going to do number 4. Very similar, but again, I'm going to be changing the colors of things, okay? HJ now is 18. So HJ is now 18. I'm going to be writing the information below. MN this time will be 28, so they're giving me a measure of the median, and they're asking me to find the measure of the opposite base. I'm going to use the same formula. Median equals 1/2 times whatever we get when I do base 1 plus base 2. Abbreviating base is the letter B now. My median is MN, which has a measure of 28. One of my bases is 18. And my other base is my unknown. I now am staring at an equation with a fraction. How do I get rid of fractions in an equation? Yeah, multiply everything, including the other side, by the denominator of the fraction, which, as you stated in this case, is 2. There's nothing different between round parentheses and square brackets other than they look different and are less confusing when next to each other.
So you get 56 and equals 36 plus 2x, right?
Okay, pause there. So I said in order to get rid of fractions in equation, you multiply by the denominator. Are we multiplying by the denominator?
Oh, so it's just
Yes.
that.
Huge, huge important skill. Put a star around that. You're going to need that moving into Algebra 2, Pre-Calculus, College Algebra, Calculus 1, whichever your math pathway takes you. You need that. Subtract 18 from both sides, and x, or rather LK, equals um, 38. All right? When in doubt, feel free to redraw the figure.
Okay.
You're welcome to redraw the figure. All right, we're going to look at number 1 and 2 now. Number 1 and 2 is dealing with first being able to identify what is it. What kind of shape is this?
It's looks like a trapezoid.
Yep, it is indefinitely a trapezoid because we only have one pair of parallel sides marked. And these other sides, I can't tell whether they're parallel or not, and I don't really have a way to prove it, so I'm going to assume that they're not. So we definitely have a trapezoid, but more than just a trapezoid, what kind of trapezoid do we have?
An isosceles, because the two bases, no, the legs are congruent.
The two legs, that is the two sides that are not parallel, the non-bases, are congruent. And that's what that little stick in the side means, is that they're congruent to each other. And so we have an isosceles trapezoid. What do we know about the angles? Because we're being asked to find the measure of the angles. What do we know about the measures of the angles in an isosceles trapezoid? Please flip back to the previous page. I believe it is the first theorem.
If a trapezoid is isosceles, then each pair of base angles are congruent.
Yep. If a trapezoid is isosceles, then each pair of base angles are congruent. Remember that the pair is along a base, not along a leg. All right, so now we need to solve this thing for x, but I have to write it as some sort of equation, and oh my goodness, what am I supposed to do? This isn't a parallelogram. Opposite angles aren't congruent.
We have to find the interior angle sum, and then we know that those two are congruent, so
We
it'd
can't
be
do
2x.
the times 180, the
Plus one.
minus 2.
Yeah, let's find how much we get when we add up all of the angles inside together, because I know that these two are going to have the same measure, and I know these two are going to have the same measure. So if I can find out how much it's supposed to be with all of them added together, I can write some sort of equation. And in order to find that interior angle sum, we do indeed use that n minus 2 times 180 formula that was being talked about earlier. Remember that the value of n is the number of sides in our figure, and the number of sides in this figure is 4. And so I have 4 minus 2, which is 2. 2 times 180 is?
360.
And so my interior angle sum for this quadrilateral is 360.
So it's 125 plus 125 plus x, 2x.
So I'm going to take all of those angles as he said, and I'm going to add them all together. He was adding some of them in his head already, in terms of having those two x's sitting there and saying 2x instead of x plus x. That is perfectly fine. So there it is with my combined like terms. Subtracting 250 from both sides. And then dividing by 2, x is
55.
You can't drive 55. Yeah? All right. Because the difficult part is getting to right here, this is the challenge. Because once you can get at the equation, it feels like the algebra skills are really, like, you're feeling really good. Okay? So I want to talk you through, on number 2, getting to the algebra equation written part. Okay? Remember, the first question you ask yourself was,
What shape is it?
what shape is it? Trapezoid. The next thing that you ask yourself is, what kind of trapezoid? Isosceles, because the non-parallel sides have the same measure. Once we know that this is an isosceles triangle, we were able to say that the pairs of base angles were congruent. And then we were able to go from here. Okay?
I mean, we know it's a isosceles triangle because the sides are congruent and
Yes.
parallel. So
Yes.
we could just repeat what we did.
Exactly.
And since it has the same amount of sides, it would be the same amount of angles.
Exactly.
So just
Yep.
40 plus 40 plus 2x equals 36.
Right. We're not going to walk through and solve it.
Yeah.
Because we did one exactly like it and you guys felt really comfortable with it. I just wanted to review again the how you get it set up. Don't die.
I'm not. I'm
Okay.
being highlighting.
Okay. All right, let's do this as our last example for the day. The one on the left or the one on the right?
The one on the right.
The one on the right.
Is always right.
The right is right. Okay, for each quadrilateral with the given vertices, they told us the location of the corners, guys. Vertices are corners. For each quadrilateral with the given vertices, verify that we have a trapezoid. So we expect it to be a trapezoid. We have to go through and confirm. Once we've confirmed, we're going to determine whether it's an isosceles trapezoid. Note, nowhere does it say we have to justify. On this case, justification isn't necessary. I'm going to justify it for you anyway,
Yeah.
as practice, so that you can see why we're getting these numbers. And if you want to justify it on your homework, even when it doesn't say you have to, this helps me know where your concern is, and I can address it to you specifically. You asked me for number 2, so that's what we're going to do. First, before we start, I'm going to write a list of the things that we need to get done. We need to draw the thing. We need to confirm that it is a trapezoid. And then we're going to see if not only is it a trapezoid, if it is an isosceles trapezoid. All right, looking at my coordinates, I see that my smallest is a -2. So I'm going to put my origin somewhere where I can get -2. Okay, those look like some good places. And now I'm going to very quickly graph it. Again, this graph doesn't have to be perfect or precise. You don't need a ruler to make the edges straight. You could use one if you wanted to, but you don't have to. We're just going to sketch it very quickly. All right, this definitely looks like some sort of trapezoid. It looks like a Pizza Hut little logo fell down and is falling to the floor. So I've drawn it. I'm happy. Now I'm going to confirm that it's a trapezoid. Remember that with trapezoid, you need one pair of parallel sides and the other pair to be not parallel. So I'm going to color code my sides to make this super easy in terms of what side I am finding slopes of. Alrighty, there we go. Which sides do I suspect are parallel?
It would be JK and
ML, yeah, JK and ML. It's an L, not a V. I know I have my handwriting. That's okay, it's my handwriting. So I'm going to go ahead and we're verifying. So we have to go through. We can't just say they look. We have to actually go through and show the work, okay? Do you need me to rewrite the slope formula for you? I'll do it once, and hopefully that should be enough for you for the rest of the examples. Please note that the formula says minus, but I wrote a plus because this y1 is a negative, and a double negative turns into a positive. Ooh. Wait. Do you see what I did? Look at my labeling. I was trying to find the slope of JK. What did I end up finding the slope of?
JL.
Yeah.
Well, that's not a line that we're supposed to have.
Does that help us with anything?
It doesn't help us with anything because that's a diagonal. And with trapezoid slopes of diagonals, they do nothing. They do nothing for us.
If they're congruent, that doesn't mean anything.
Except,
They're parallel.
yeah, well, that's the, yeah, the slope of. Hey guys, please watch what I'm writing as you're copying it down, and if I label the wrong point, like tell me please,
It's
'cause
alright.
don't ever trust me. Dear Lord, when it comes to writing these sorts of things and there's numbers and letters involved, don't trust me. Please make sure that I'm grabbing the right stuff. Because here's the thing is, there's like 20-ish of you in this room, and I am doing my very best to try to mentally keep tabs on facial expressions and what they tell me about whether you're understanding or even like wanting to be here today, and whether I need to be softer and calmer or I need to be like crazy, right? While talking through what I'm doing and writing it and right? This is last year all over again. What was I doing? Okay, I was doing this. And I was doing that. And hopefully this time I would get, okay. I got a different, the number really didn't mean anything, which is why I didn't notice until I got to this point. Here's when I noticed. I want ML. I started to grab KL and I went, oops, did I mess up? Okay, so that's when I noticed. Okay. Hello, stay with me. What? What did I do? Oh, wait. I can't.
Miss, spoiler alert, they're gonna be congruent.
Spoiler alert. No, these are slopes. Slopes are not congruent. Slopes are equal.
Oh yeah, the slopes are
Congruent, same
which means they're
size,
parallel.
same shape, and a slope doesn't have a size. or a
It
shape.
doesn't. It's a magnitude. It's a value.
Oh, they're parallel.
They're parallel,
That's
which we're very happy about. But we need to check the other sides. We suspect the other two sides are not going to be parallel because they totally don't look parallel, but I could have been even way crazier than I just was.
if they are, then it's not a trapezoid.
Right. And which means I drew stuff really wrong. Okay, here I go. I'm going to do M and J. And K and L. That says undefined. I can't write. I don't know what I was thinking. All right, one's horizontal, one's vertical. We don't care whether they're perpendicular or not. They are, but we don't care. All we're asking ourselves is, are they the same? Are these the same? No. So these are not parallel. All right, so do we have a trapezoid?
Yes,
Yes. Why?
because there's a pair of parallel lines.
And only one pair. Hi, there's a lot of off-topic conversation. Only one pair of parallel lines. Now we need to confirm if this is an isosceles trapezoid. We've got two ways that when we're on graph paper that we can do it. And both of them require congruent things. Both of them require distance formula. Either diagonals are congruent or legs are congruent. Which one do you want to see?
Legs.
Legs? Okay. So we're going to check to see if the legs are congruent. Which means our dear old friend, the distance formula. Hashtag sarcasm, guys. I really don't like this formula. Not because it's hard, but because it's easy to get lost in. And as I got so lost on slope earlier, I'm scared. Okay, one leg is ML. Wait, MJ, never mind. Okay, MJ. Here I go. M and J. Okay. I'm so nervous I'm gonna mess up, y'all. I have not had a good track record with the numbers today. Oh, dude. Wait, look. No. Oh, yeah, no, you're right. I put subtraction. You're right. You're right. Thank you. What do I notice about those sides? They're on the grid lines, aren't they? 1, 2, 3. 1, 2, 3. Oh, thank goodness. I had a shortcut and I didn't see it. Are the legs congruent?
Yes.
Yes. So is this an isosceles trapezoid?
Yes.
What was the reason?
Legs are congruent.
Because the legs are congruent.
And we done. Thank you very much.